Hello, Algebra 2 students. This is Mr. Villanueva. We're going to be doing Module 2, Lesson 6. Okay, so Lesson 2-6, which is right up here. Solving systems of inequalities. Today's goal is to solve systems of linear inequalities in two variables. Here's some of your vocabulary: system of inequalities, feasible region, bounded, and unbounded. Okay, so we're going to talk about solving systems of inequalities in two variables. A system of inequalities is a set of two or more inequalities with the same variables. The feasible region is the intersection of the graphs. Ordered pairs within the feasible region are viable solutions. The feasible region may be bounded. If the graph of the system is polygonal region or unbounded, if it forms a region that is open. So key concept to solving system of inequalities. Step 1, graph each inequality by graphing the related equation and shading the correct region. Step 2, identify the feasible region that is shared for all of the inequalities. This represents the solution set of the system. And they give you a study tip here. Okay, this formula right here should look very familiar to you guys. You guys have been working with this for at least 3 years. We're in Algebra 2, so at least by algebra and geometry and now Algebra 2. Okay, so basically all these are y equals mx plus b, but they have different symbols. We have the less than or equal to, we have the equal sign, we have the less than, greater than or equal to, and greater than. All right, so we're going to take a look at solving the system of inequalities here, okay? And notice it says unbounded region. Okay, so we have y is less than or equal to 4x minus 3. And yes, the answer is solid here. We're going to use a solid line to graph the first boundary, y equals 4x minus 3. We're using the line equals because there is an equal up here. And anytime you see an equal sign, for example, this one, or even this has an equal line, you will use a solid line, okay? That means it includes that line, that it can be equal to this, or it can be less than or greater to, whatever is stated. Here it says less than or equal, so it can be these points on the line. Therefore, this line is going to be solid. So use the solid line to graph the first boundary, y equals 4x minus 3. And as you all know, this right here is our y-intercept at -3. So 1, 2, 3, here's our -3. And our slope is 4, which means we go up 4, 1, 2, 3, 4, and over 1. So this is our 4x, our y equals 4x minus 3. Okay, the appropriate half plane is shaded yellow. So because this right here says less than or equal to, we're going to shade the less part. Now, how do you determine what is less? Here is our line, and it's saying that this whole side right here, I know this is green, but once it's supposed to be all yellow, and then when we cover it with blue, it'll be green. But right now, it's this. All this is yellow. How do we determine which side is less? Okay, the way I think about this is if this is a pencil, and I'm holding on to the pencil at the very top, the very point of it, and I let go, what side is it going to fall on? It's going to fall on this side. So basically, it's going to smash everything over here. If I drop the pencil, this line here will come crashing down, smash everything on this side. Therefore, that is the lesser side. This over here would be the greater than. Okay, so right here, this is less, and it's going to be yellow. The appropriate half plane is shaded yellow. Use a blank line to graph the second boundary, y equals negative 0.5x. The appropriate half plane is shaded blue. Okay, so here, first we need to isolate y, so we divide by -2, and then if we divide x by -2, that does equal -0.5x. Okay, as you can tell, there's no y-intercept, so it's going to go through the origin, and then it's going to have a negative half slope. So -1/2. So we go down 1/2, 1, 2, and this is the line. Okay, you should use a dashed line because there is no equal sign. Remember, only when it has an equal sign is it going to be a solid line, because that includes it. This is saying everything that it is not equal to. Therefore, we have a dashed line. Use a dashed line to graph the second boundary, y equals -0.5x. The appropriate half plane is shaded blue. So here we have our dashed line, and it should be that y is less than. Okay. When you do this, this will be less than. Okay. When you work out this problem. Therefore, everything below the line will be shaded. Okay. The solution of the system is the set ordered pairs in the intersection of the graphs shaded in green. The feasible region is right here. Okay. And it's going to be unbounded. Okay, it's unbounded because it can go forever in these two directions. There's no boundaries. It's going to go on forever. Okay, let's look at the next study tip. It says boundaries. The boundaries of inequalities with symbols less than and greater than are graphed using dashed lines, indicating that the ordered pairs of the boundary are not included in the feasible region. So remember, no equal sign. It's not going to be a solid line. These do not have equal sign. It's going to be a dashed line. Okay, and let's see, check. Test the solution by substituting the coordinate of a point in the unbound region, such as 2, -3, into the system of inequalities. If the point is viable for both inequalities, it is a solution of the system. So they chose 2, -3. If we look over here, here's 1, 2, and then -3, 1, 2, 3. This is in our intersection. So, but let's check it. Okay, so if we plug in 2 for x and -3 for y, we come up with this equation, and then -3 is less than or equal to 5. Is that true? This does check, so this is good. Same thing for the other side. We've got -2, and in place of y, we're going to place -3. And in place of x, we're going to place 2. -2 times -3 is 6. 6 is greater than 2. So this solution does work. Okay, now it says check. It says graph the solution of the system of inequalities. Okay, I am unable to draw these equations here, so we're just going to go to example 2. Okay, so each one of these are graphed. We have y is less than -4/3 x plus 5. So here's our y-intercept. It's going to be at 5. So 1, 2, 3, 4, 5. And it's going to have a slope of -4 and 3. So down 4, 1, 2, 3, 4 over 3, 1, 2, 3. Okay. And as you can see here that there's no equal sign, so this line will be dashed. Okay. All three lines are labeled. Notice that this one here has an equal sign. So this one is going to be a solid line, which is here. Okay. So for this first one, it says y is less than. So here we have our dashed line. And we're going to graph everything below. And then here's the next line, y is greater than or equal to x minus 2, which is this line. And it will be a solid line. Okay, and that's going to be greater than or equal to, so we're going to shade everything up here. And then we also have x is less than, or I'm sorry, x is greater than 1. So here's x equals 1, or x is greater than 1. Notice it's dashed. And on this one, we're going to shade all of this side. Okay, because x is getting bigger going this way.